Another very useful property is the telescopic sum. The sum of f of I plus 1 minus f of I from I equals m to n is equal to f of n plus 1 minus f of m. So to have a proof on that, the summation of f of I plus 1 minus f of I from I equals m to n is equal to, where I is equal to m, so f of I, which is f of m, plus 1 minus f of m. Next, plus, the next term is m plus 1, so f of m plus 1 plus 1 is f of m plus 2 minus f of m plus 1. Now our I is equal to m plus 2. So f of m plus 2 plus 1, that's f of m plus 3 minus the f of m plus 2, and so on until to the last term, which is the f of n plus 1 minus the f of n. So we could cancel the terms here. So f of m plus 1 minus f of m plus 1. F of m plus 2 minus f of m plus 2. The f of m plus 3 is also deducted somewhere here, which is not written, but it's part in the dot dot dot. And also the the f of n is also part here. So leaving the f of n plus 1 minus f of m. That's the telescopic sum. Okay, this is an example of a telescopic sum. So the summation of square root of I plus 1 minus the square root of I. So the form there is f of m plus 1 minus f of I. So here it's just um there is a little modification, which is the radical sign. So square root of I plus 1 minus square root of I from I equals 1 to 99. If we are going to manually add all the terms here, so first let's identify the terms. So I is equal to 1, so that's square root of I plus 1 minus 1. So next is I is equal to 2, so that's square root of 2 plus 1 minus square root of 2. Next, I equals to 3. So the square root of 3 plus 1 minus the square root of 3. And so on. And let's identify second to the second and last term. So that's 98. So the square root of 98 plus 1 minus 98. And the last term plus square root of 99 plus 1 minus square root of 99. So let's simplify this first. 1 plus 1 is 2, so square root of 2 minus square root of 1. Square root of 2 plus 1 is square root of 3 minus square root of 2. And then square root of 3 plus 1 is square root of 4 minus square root of 3, and so on. And then the square root of 98 plus 1 is square root of 99 minus square root of 98. And lastly, square root of 99 plus 1 is the square root of 100 minus square root of 99. Okay. So, first, let's cancel all the cancelable terms. Square root of 2 minus square root of 2. Square root of 3 minus square root of 3. Square root of 4 is also cancelable somewhere here on the dots. And square root of 99 minus square root of 99. Square root of 98 is also cancelable here. It's not found here. So, and I bilin, square root of 100 minus square root of 1. So square root of 100 is 10, and square root of 1 is 1. So 10 minus 1 is 9. So if we're going to apply the telescopic sum, so the sum of f of I minus f of I is equal to f of n plus 1 minus f of I, f of m. So so here the telescopic sum, the square root of n, f of n, so that's 99, plus 1 minus the square root of f of I, which is 1. So 99 plus 1 is 100, so square root of 100 minus square root of 1, that's 1, so 10 minus 1 is 9. And that's it.